Hello everyone, welcome to this session on synthesis and RTL coding. So we have been discussing about the partial case and the improper case and incomplete case, improper if statements. So in the previous lab session we saw how a incomplete if can cause inferred latches and cause undesired behavior. In a similar way we are going to discuss the case statement in this lab session in detail. So let me start with this. I'm opening all the files that are needed. These are the 4 files we are going to use in this lab. So let's start with incomplete case. Okay, like incomplete if we have an incomplete case also. Let's look at this statement. Okay, and as we discussed in the incomplete if case also, we will look at the Verilog code, we will look at the Verilog simulation, functional simulation, and then we will look at the RTL synthesis and see what happens in all the 3 cases. Okay, so let's get started. Let's first understand what we expect here. Let's look at that first. Okay, so we have inputs I0, I1, I2. That's a select line and that's the output Y. So we are having a case statement. The case statement will also translate into a mux. The select line is a 2-bit line. So select of 1 and 0. 1, 2, 3. This is my Y. So if select is 0, 0, I get I0. If select is 0, 1, I'm getting I1. Now select is a 2-bit signal. It can take a values of 1, 0 and 1, 1 also. But for these 2 cases, nothing is specified. And default statement is also not coded. So it's going to latch. This is going to be a latch. Correct. Correct. So what will be the latching condition? Let's look at it. Now when select is 0, I0 is connected. So let us look at this as a truth table. So I'm going to write cell of 1, cell of 0, and what is Y. So 0, 0, 0, 1, 1, 0, 1, 1, correct? So in these 2 cases, I'm going to have a latching action because of incomplete case. When it is 0, 0, I'm getting I0. When it is 0, 1, I'm getting I1. So clearly it shows that whenever my select is 1, whenever my select is 1, I am having a latching action. So this can be connected to select of 1 directly, correct? Whenever select of 1 is 1 or select of 1 bar, correct? Whenever select of 1 is 0, my latch is transparent. Whatever is here will be seen here. When select of 1 becomes 1, the value is latched, correct? So select of 1 should be 0. That's what it is. When select of 1 becomes 1, there's a latching action. And here I will have my mux, which is driven by cell of 0, where I will have, when select 0 is 0, I will have I0, I will have I1. This is the expected logic we are expecting. Okay, this is what we are expecting. Let's see what happens. Okay, so first let us do the functional simulation. So to do the functional simulation, it's going to be iVerilog. So we looked at incomplete case, and the TB will be also TB underscore incomplete case dot slash a dot out GTK wave TB incomplete case dot VCD. So let's load the VCD and check what is happening. So this clock and reset are test bench signals. You need not worry about it. What signals are present in the RTL? That alone we will I0, I1, I2, select and Y, correct? So clearly look at this. When select is 0, 0, correct? In this window from here to here, select is 0, 0. When select is 0, what we are expecting? When select is 0, we are expecting it to follow I0. It's clearly following I0, correct? Let me make I0 in some color. I0, I'll make it in red color. I1, I'll make it in orange color. I2, let it be in green. I select, I will make it in blue. And this one also, let this be in green. Okay. So if you see here, clearly it's following I0, correct? When select is 0, my Y is following I0, correct? When select is becoming 1, it is following I1, correct? Now, the moment when select is becoming 1, 0 or 1, 1, it is latching on to the value. What value? The value of Y, which it was before. So the value of Y was 0 by the time it became 1, 0. So it's latching on to that action completely. It's latching to that value, correct? Clearly it is latching in this region, correct? In this region completely. It's latching. Here it is following I1, here it is following I0. This is what we expected. And this is what we are seeing in the functional simulation. Let's see what happens when we synthesize it. So I have the synthesizer readily loaded. So read Verilog. I have done the read liberty. So I'm directly starting with read Verilog. Read Verilog incomplete case dot v synth hyphen top incomplete case. So whenever we are doing synth hyphen top, we need to look at the cell. What are the cells it is inferring? That is very, very important. It's going to give a lot of clue. See, we are seeing some mux and nor all those things inferred, but it's also inferring a latch, which we didn't expect. Means when we are writing the RTL, we didn't expect, but when we analyze the RTL, we expected that yes, latch will come. So ABC hyphen liberty lib sky130.lib. We are going to show the design. Yeah, there we go. So clearly, you see, there is a latch which is driving Y. This is what we expected, correct? There's a latch which is driving the output Y. This is the output Y, correct? This is getting driven by a latch. This is the output Y, correct? This is getting driven by a latch, correct? Now, what is the enable condition for the latch? Cell 1 bar. This is what we expected. Let's see what is happening here. This is my select. So select 1. It's going through an inverter. So this is cell 1 bar, and that is the enable condition for my latch. And this is going to be the muxing logic. Exactly, this is going to be the, if you simplify this is going to be the muxing logic, which is going to implement this function on the D pin of the flop or the latch, this condition. So cell 1 has no role in that. It's a function of I0, I1 and cell 0. So clearly if you see here, that's what we are seeing. Yeah, of course, I1 has to be low here, correct? No, sorry, cell 1 has no role. So if you see cell 1 has no role in this. This logic is a purely a function of I1, I0 and select of 0. Of course, cell 1 should be 0, right? Select of 1 should be 0. That's what we are checking here. Throughout this logic, cell of 1 should be 0. Correct. Cell of 1 should be 0. Clear? So this is what we expected and this is what we are seeing here. This is clearly in alignment with our understanding. Okay, now let's go to the next exercise. So we saw incomplete case. Now let us look at complete case.